Watch the complete playlist on the app Pions. Download the app now.
So let's start with our question number one. Question number one says differentiate with respect to x. Okay. So this thing with respect to x, what? Root under e. Okay. X root. Okay. So let me write, I think this is a typo, or let me just write it as we are differentiating with respect to x. Okay. This whole thing we have to differentiate with respect to x. Now pay attention. Okay. So here we can write it as d by dx. How do we write it? D by dx of, okay, d by dx of x root under e to the power root x, right? We are differentiating this. Now, when you are differentiating this x is in multiplication with this. So let's just rewrite this expression in a much simpler manner. D by dx of x into e x to the power half whole raised to power half, because root is what? Root is power half, right? And x is multiplied with this. Now what we will use here? We will use multiplication rule. So multiplication rule says first you differentiate the first term. So d by dx of x, keep the other term constant. So e x raised to half whole raised to half. I am not doing anything with this. Okay. Plus, let's keep x constant and differentiate the second term. So d by dx of e x raised to half whole raised to half. Okay. Now what is the differentiation of x? So derivative of x is nothing but 1. Clear? So derivative of x is 1 and the second term will remain as it is. So now anyways it will remain same. So I'll just keep it as it is, the question, the way they have written in the question. So root under e root x. Okay, because nothing we have to do with this. So let's keep it like this, plus x into, now let's differentiate the second term. Now, always remember, first we will give preference to the outer power. Which power? This one. Because this is our power of the main function. This is our main function, power. So power will come in front and this will be e x raised to half whole raised to minus half. Let me repeat again. I did what here? I have differentiated the power first. So power will come in front and whole function raised to power minus half. Done with the power. Let's go inside the bracket. Now inside the bracket it is e to the power something. So derivative of e to the power something is e to the power something only. Correct? Nothing to do with x raised to half. Done with e raised to something. Now e raised to something is done. Now what we have to do? Differentiate this something. So that is x raised to half. So half will come in front. X raised to minus half. Again I am repeating, keep brackets to avoid mistakes. Otherwise, by any chance, if there is a negative sign and you are putting here negative and there is no bracket, it looks like you are subtracting it. So put a habit. By now you should have this habit that you are keeping brackets and it should be clear. Like if somebody is looking at this, you can see here that I am differentiating stepwise each one of them. First power, done sir, then function, done sir, then x to the power half, done. Clear? Now our final result for this particular problem will be root e raised to root x plus, now be careful, all of them are multiplied. So how do we simplify now? By now you should learn these simple tricks also, how to write it in a better way. So half, this half and this half, okay, this will be 1 by 4 because they are multiplied together, right? 1 by 4. This x to the power 1 and this is x to the power minus half. Let me repeat again, x to the power 1 and x to the power minus half. So powers add up. So x power 1 minus half. 1 minus half is half. So x to the power half. Again, I am repeating. This is x raised to this one. Look at the pointer. X raised to 1 and this is x raised to minus half. 1 minus half is half. Done. What we left with? We left with this one. So this is our actual problem. Let's write it in the, oh wait, this is power minus half. So minus half will be written as 1 upon e x raised to half whole raised to plus half. I took that negative sign inside. Sir, what if I leave it like this? No problem in that. Okay, you can leave it like that if you want to. E x raised to half. So e x raised to half, which means root x. Correct? Now, if you want to further rewrite this expression, this is nothing but our actual problem, right? So here, let's rewrite it as root under e root x. Done. This is our final answer for question number 1. Let's move to question number 2 now. I hope all of you understood question number 1. So question number 2 says differentiate with respect to x, all of them have with respect to x only. I think I missed in all of them this. Okay, so you have to differentiate with respect to x this given factor. Clear it is? So d by dx of cos x cube bracket, now be very careful with the bracket, sine square x raised to 5. Clear? So here there are two functions, one is cos x cube and another is sine square x raised to 5. Be very careful, this is in product. Okay, this is not a part of this because that is a separate bracket, so they are in product. So again we will use multiplication rule, and multiplication rule says first you can differentiate anyone because there is in between addition. So I am differentiating, I am keeping this sine square x raised to 5 d by dx of cos x cube plus cos x cube as it is d by dx of sine square x raised to 5. Okay, now let's differentiate. How to differentiate? Let's keep this sine square x raised to 5 derivative of cos x cube. Okay, so let's keep a first bracket because differentiation of cos is minus sign. Be very careful. If you will not keep this bracket, it looks like they are getting subtracted, but they are actually multiplied. So minus sine x cube. Now done with the cos, differentiation of x cube, 3x square plus cos x cube as it is, derivative of sine square. What we will do? 2 will come in front, sine power 2 minus 1, which is sine x raised to 5. Derivative of x raised to 5. 5 will come in front, x raised to 4. I hope this is clear. So this is our complete, but I think I missed one more parameter here in the second one. Power is done, 2 will come in front, 2 sine x raised to power 5. I didn't differentiate sine. So here there will be one more parameter, cos x raised to 5. Be very careful with these mistakes. So let me repeat again, differentiation of sine square x raised to 5 is 2 will come in front, sine raised to 2 minus 1, done with the power. Then differentiation of sine theta will be cos theta over here. And finally, the angle is x raised to 5, which is 5x raised to 4. You can leave it like this. Okay, this will be our complete answer to this particular question, question number 2. Fine. Let's move to question number 3. Question number 3 again says differentiate with respect to x only. I missed x in each statement, I think. So wait, let me go back. So differentiate with respect to x, log of sine log x, correct? So let's differentiate this. So first of all, d by dx of log of sine log x. Okay, be very careful. Sine log x. So there are few things you have to be very careful. Sir, is log multiplied with sine? No. Sir, how do you judge it? Because log is a function, and whenever you have a function, it is operated on some variable, like trigonometric functions, like exponential functions. So like all other functions. Okay, so log is operated on this. So this is a part of log function. Clear? Similarly, this log x is the angle for this trigonometric function. So be very careful with these things. You can't assume that log is multiplied with sine and differentiation of log. Log is having no sense if it has nothing in front of it. Be very careful with these things. By now, you should be clear with this. So let's use the chain rule. No multiplication rule here because this is the angle, or sorry, this is the value of this log. Log is operated on this particular value. So derivative of log of something, sir, 1 upon something. This we have learnt in our regular lectures. Derivative of log of something is 1 upon something. Done with this. Next is sine. Derivative of sine. Sine is cos of log x. Done with that. Sine derivative is cos. And finally, who is left? Log x. So derivative of log x, 1 by x. Done. This is our complete answer. So let's rewrite it in a simple manner. Let's simplify it in case if you don't know. 1 by x cannot be simplified further. So let's write it as it is. And cos of theta upon sine of theta. Theta here is log x. So cos theta upon sine theta, cot theta log x. Done. This is our question number 3. Let's move to question number 4. Question number 4 says, again, differentiate with respect to all of them are x only. Differentiate with respect to this. With respect to x, this particular function. Again, I am repeating what I explained in the previous question. Log of something. That something is the part on which the log function is operated. So log of this thing will be derivative of log of something 1 upon something. Log of something is 1 upon something. And derivative of sec theta. So sec theta tan theta plus derivative of tan theta sec square theta. Clear? Sir, can we further simplify? Let's try it. Let's take sec x common from the numerator. We left with tan x plus sec x. And what is there in the denominator? Sec x plus tan x. Let's cancel out this sec x plus tan x with sec x plus tan x, and our answer to this particular question is sec x. I hope this is clear. This is our fourth question. Okay, let's move to question number 5. Let's see question number 5. Question number 5 says, differentiate with respect to x this particular function. So let's differentiate it. D by dx of log of x whole divided by 1 plus x log x. Be very careful. Multiplication rule, division rule, chain rule. Okay. Many things will be operating here. Clear? How we will apply that? Let's focus. Okay. In case if you are not familiar with division rule, let me write here d by dx of u by v. U is numerator. So always remember this identity with as a numerator and denominator, not u by v. It will help you that we always differentiate the numerator first because there is a negative sign here. If by any chance, if you differentiate the denominator first, the things will go wrong. So v du by dx minus u dv by dx whole divided by v square. This is our division rule. Correct? So what we will do now here, we will apply this division rule here. So this will be numerator first. So 1 plus x log x as it is. D by dx of log x. Numerator first. So I am putting here implies that minus log x as it is. D by dx of 1 plus x log x. I hope this is clear. Whole divided by 1 plus x log x whole square. Majority of people do what? They forget about this v square in the denominator. So you have to be very careful with this. Okay, great. Let's move ahead. So this will be 1 plus x log x as it is because no operation is done on this here. Derivative of log x 1 by x. So I'm putting it below here only. Log x is 1 by x. So you can put it here. Minus log x as it is. Derivative of 1 is 0. Derivative of x log x. Now they are multiplied. Be very careful. So don't forget about multiplication rule. X log x. So derivative of x is 1 and log x into 1 by x. Let me repeat again. Differentiation of x is 1. Log x as it is. X as it is. Derivative of log x 1 by x. So by now you should know these things easily. 1 plus x log x whole square. Clear it is? Now x and this x will cancel out. So we can cancel these two. And we left with here 1 plus x log x upon x minus log x into 0, no effect. What we left with there? 1 plus log x whole divided by 1 plus x log x whole square. Clear? So let me write remaining part on the left hand side here. So we will left with 1 plus x log x, 1 plus x log x. And when you cross multiply, x will go on the right hand side, x log x into 1 plus log x whole divided by x will go down and this will be 1 plus x log x whole square. Clear it is? Now if you want to take common, now nothing is getting common here. Okay, so you can leave this as a answer for fifth one. Let's move to question number 6. Question number 6 says differentiate again with respect to x, x raised to sine x. Clear? Our function here is x raised to sine x. Sir, can we use multiplication rule? No, they are not multiplied. Can we use division rule? No, they are not divided. Can we use chain rule? Here we can't. Why? Because here there is a function in the power of function. So first we have to simplify it. Again, I am repeating this technique which we are using right now in question number 6, that is for function to the power function. Sir, what to do in function to the power function? We simply take it as u or v. U is equals to x sine x. Let me be very clear with this. So now if I take log both the sides, so log of u equals to sine x log of x. Which property? Property is log a to the power anything b will be b log a, in case if you are not familiar. So sir, how will you know? By now you should know these things. But again I am repeating. How do I know this? I know this because it is function to the power function. Whenever there is a function in the power of another function, direct guess must be logarithmic method. No other option. So it's not like sir take sin x in front and make sin x minus 1. It is straight away wrong. Be very careful. Okay, great. Now you have this thing. Let's differentiate both the sides. So log u will be 1 by u and du by dx. And on the right hand side, when you differentiate, correct? So we will use multiplication rule, sin x as it is, derivative of log x plus log x as it is, derivative of sin x. Now du by dx will be taking u on the other side, derivative of log x 1 by x. So this will be sin x upon x plus log x as it is, derivative of sin x cos x. Let's take u on the right hand side. Sorry, u, let's substitute. Here it will be x raised to sin x upon x plus log x cos x. And what is this? On the left hand side, this is the differentiation of u. And what is u? X raised to sin x. So when you differentiate this, you get this. This is your correct answer to question number 6. Let's move to question number 7. Again, a typical problem of logarithmic functions. Why? Because functions are in power of functions. Variables in power of variables. Such cases, we what do? We do logarithmic ones. So let's take u is equals to x raised to x raised to x. But wait, sir. We know that log of something will get the power in front. How to deal with x raised to x raised to x? So log of u will be equals to how much? X log of x raised to x. Correct? Okay. So if you take it like this, you will get this. Okay. Okay. Because only first power you can take it out. Highest power, and you left with this. But again, sir, we will get stuck at later stage. Okay. So what to do with that? We will see that later on. Right? So be very careful. Quite important question. Log of u. Let's differentiate it. It will be 1 by u du by dx. Correct? And if we differentiate it, sir, first differentiate x. Keep the log x raised to x as it is plus x as it is, differentiation of log x raised to x. Now du by dx will be equal to u. Take it u on the other side. Here it will be derivative of x1 log as it is plus x as it is. Now be very careful. Derivative of log of something 1 upon something. Now we will get stuck. Differentiation of x raised to x. We got stuck here. Okay. You can't leave it like this. And neither you can take that x in front and x to the power x minus 1. That is wrong. Because this is function in the power of function. It's not a number in the power of a function. No. That power will come in front only if it is a number. So be very careful. Then sir, what to do here? Let's solve it separately. Let's take v equal to x to the power x. And log of v will be x log x. Correct? So derivative of log v, 1 by v dv by dx. And x log x, let's use multiplication rule again. So derivative of x is 1 plus x as it is, derivative of log x, 1 by x. dv by dx will be equals to v. What is v? We will substitute within a minute. Log x plus x into x, 1. 1 second, what happened? Yeah, plus 1. Now, let's substitute the value of v. So d by dx of x raised to x is equals to x raised to x 1 plus log x. We got our answer for derivative of x raised to x? Yes. Plug it here. Clear? So let's substitute. What is u? X, x, x log of x raised to x. X upon x raised to x. Derivative of x raised to x, just now we found x raised to x 1 plus log x. Done. Can we cancel, sir, this x raised to x with x raised to x? Yes. So our answer will be x raised to x raised to x log of x raised to x plus x into 1 plus log x. When I'm solving, you might find it very easy, but be very careful. When you will actually solve this again, then you will get stuck. So this is our final result for question number 7. Let's move to question number 8 now. Great. Our next question is differentiation with respect to x only. 8 raised to x upon x raised to 8. Okay. Beautiful problem. Looks very easy. And though it is very easy, but students get stuck by looking at this. X raised to 8. Now, since we have done logarithmic ones, so be very careful. You have to be very particular about what to choose, which one to choose as logarithmic one and which one not to. Okay. Let's see that. So first of all, differentiation d by dx of 8 raised to x whole divided by x raised to 8. Division rule. What is our division rule? Our division rule says, sir, leave the denominator as it is, differentiate the numerator of 1 first, minus numerator 1 as it is, differentiation of denominator. Okay, x raised to 8 whole divided by x raised to 8 whole square. Now, first one, differentiation is 8 raised to x. Sir, what to do with 8 raised to x? 8 raised to x, there is a direct formula. In case if you don't know formula, simply take 8 raised to x as u, take log both the sides and you can get the result and substitute here. But otherwise, you have this formula. If there is a number, a is a number, and number to the power x, be very careful with this. Only it is true for x. What if a instead of x, it is sin x, x square, it will not be true. So only if there is a number, a number can be anything, not necessary 8, 2 to the power x, 10 to the power x, 30 to the power x, anything, then this will be a raised to x log a. This is our result. So here it will be x raised to 8, 8 raised to x log a. A is what? 8. Minus 8 raised to x. This is our direct formula, first formula of differentiation. 8 will come in front, x raised to 7. Whole divided by 8 and 2. You know that will be multiplied and it will be x raised to 16. Clear it is? So this is our complete differentiation of question number 8. Okay, though it looks confusing, but it is very simple. Let's move to question number 9. Great. Done with simple differentiations, logarithmic differentiations. Let's move to parametric form. Sir, what is parametric form? A function dependent on some other variable, like x is a function of theta, y is a function of theta, and they are saying find dy by dx. This is called parametric form. So dx by d theta we will have to find. Let's figure out dx by d theta. Sir, why dx by d theta? Because here it is theta, a function. A, B, C are constants, so theta is a variable. If instead of theta, sir, it was t, then you will differentiate dx by dt. If it is any other variable, you have to do that way. So dx by d theta, let's write here value of x. X is a function of theta, a theta plus sine theta. I hope this is clear. Now here we will take this a out and differentiate d by d theta of theta plus sine theta. Now what is the derivative of theta? Derivative of theta is 1 and derivative of sine theta, be very careful, cos theta. This is our dx by d theta. Let's find dy by d theta here. So dy by d theta will be d by d theta of y. What's y? A 1 minus cos theta. Clear? A is a constant, can be taken out. So differentiation of 1 minus cos theta. And what's the derivative of 1? Sir, 1 is 0. So 0 minus derivative of cos theta minus sine theta. Be very careful with this. So minus minus plus. So it will be plus a sine theta. This is our dy by d theta. But they are asking dy by dx. Yes, not dx by d theta or dy by d theta. So dy by dx, we can write it here as dy by d theta. Be very careful. If you did opposite, the things will give you a wrong result. Dy by d theta upon dx by d theta. Some students, even after doing up till here, they go wrong where they do dx by d theta divided by dy by d theta. So be very careful. So this will be a sine theta upon a into 1 plus cos theta. Let's cancel out a with a. So we left with sine theta upon 1 plus cos theta. Now, sir, if you want to simplify further, you can, or otherwise you can leave it like this. But I would recommend that you should know simplifications by now, because boards are approaching. So sine theta, you can further simplify as 2 sine theta by 2, half angle formulas, cos theta by 2, and 1 plus cos theta is 2 cos square theta by 2. So when you cancel this 2 with 2, cos theta by 2 with 1 of the cos theta by 2, you left with tan theta by 2. Now that's a simplified version of this one. So they can ask you like, show that dy by dx is tan theta by 2, like this. This was our 9th problem for today. Let's move to question number 10 now. Okay. Now here you can see this is a typical and most common type of problems usually asked in exams. Okay, where you have to show. When you have to show, you don't have any choice. You have to simplify. Okay, otherwise if only differentiation will not work. And these have more weightage than ordinary differentiation problems like we did in the previous case, where you don't have to simplify at that. Now here you are forced to simplify. Your answer is should be minus y by x, right? So let's differentiate it first of all. Can we differentiate it directly? No. These are the functions of t. So first find dx by dt, parametric form dx by dt. So dx by dt will be derivative of d by dt of, I'm rewriting this as a whole raised to sine inverse t whole raised to power half, correct? So let's start with our simple chain rule. Power half will come in front. A raised to sine inverse t whole raised to power half minus 1. Done with the power, keep a huge bracket. Let me repeat again, keep brackets to avoid mistakes. 1 by 2 comes in front, whole raised to power minus half. Which differentiation we did? Power. Next is after power a. A to the power something will be a raised to something log of a. Just now we did in the previous questions. Done with a raised to something. Okay, let me repeat again. First is power, then is a raised to something. A raised to something is a raised to something log a. Finally, who is left now? Sir, sine inverse t. Sine inverse t is 1 by root under 1 minus t square. Done. Correct? Sir, what about this t? Derivative of t is 1. So no need of doing this. Clear it is? Again, if you are confused, let me repeat for you once for the last time. Power will come in front and the whole function to the power minus half. Done with this. Secondly, a sine inverse t will be a raised to sine inverse t log a. We differentiate this function. And finally, sine inverse t will be 1 by root under 1 minus t square. This is dx by dt. Let's find dy by dt similar way. So dy by dt, you can see the expression is huge. So be very careful with small mistakes. So this will be a cos inverse t whole raised to half. Let's proceed in a similar fashion. Half will come in front. The main function to the power minus half. Done with that? Then derivative of a to the power something. A to the power something log a. Finally, derivative of cos inverse t minus 1 upon root under 1 minus t square. Be very careful with this. Great. So you got dx by dt and you got dy by dt. Now what we have to do? Just now we did previous question. So we have to divide both. So let me write here dy upon dx is nothing but dy upon dt whole divided by dx upon dt. So dy by dt is this whole huge expression. Let me write it for you. Half a raised to cos inverse t minus half a raised to cos inverse t log a minus 1 by root under 1 minus t square. Many things will get cancelled, so be very careful. Half a raised to sine inverse t whole raised to minus half a raised to sine inverse t log a root 1 upon root under 1 minus t square. Let's see what is getting cancelled. Sir, this half is getting cancelled with this half. Great. Sir, can we cancel these two? No. One is cos inverse, one is sine inverse. You can't. Okay. Next is log a, log a. And 1 by t square, 1 by t square cancelled. Clear? Nothing is left, only this negative sign, which students usually ignore or forget about this. There is a negative sign here. And then they think about, sir, where is the negative sign? This negative sign. And rest these cos inverse and sine inverse terms. So let me write it here. This will be a cos inverse t into a cos inverse t whole raised to minus half whole divided by a sine inverse t into a sine inverse t whole raised to half minus half. And there is a negative sign also. So let's substitute, let's put a negative sign here on the top. Okay, I'll place here. Okay, let me make it a little more dark. So this is our negative sign. Okay, so let me write the remaining part of this question over here on the top. We have little space here. Dy by dx equals to negative. Be very careful. A raised to cos inverse t. A raised to cos inverse t. If I square this, y square both the sides, y square will be a raised to cos inverse t. So y square into a raised to cos inverse t raised to minus half. Minus half will be 1 upon. So this will be into 1 upon y. Sir, how you got 1 upon y? Let me repeat this. Minus half can be written as 1 upon a cos inverse t whole raised to half. Correct? A raised to cos inverse t whole raised to minus half can be written as this. And half is nothing but 1 by root under a raised to cos inverse t. And 1 upon this is root under a cos inverse t is y. So I just wrote it as 1 by y. Okay. Let me repeat again if you are confused. Power minus half means it goes in the denominator and root is already there in y. So that's why it is y. Okay. So let's remove this. So we got y. We will make use of same thing in case of x also. Whole divided by a raised to sine inverse t x square into 1 upon x. So this will be y square and y cancels minus y upon x. That is dy by dx. This is our question number 10. Let's move to 11th one now. Okay, our next question, 11th one. Again, a typical type of problem where you will have to show something, where you will have to prove something. When you have to prove something, you have no choice. Even if your differentiation is correct, if your final answer is not matching this given thing, they'll not give you full marks. Like many students, they have this issue that they go for differentiation properly, and at the end their answer is not matching. Okay, and they expect that they should get marks. No. Why? Because they are saying show that this is equal to this. So if y is equals to this, let me write here y equals to a sin x plus b cos x. Let's find dy by dx. So dy by dx will be derivative of a sin x, a cos x, and derivative of cos x minus sin x, so minus b sin x. Sir, why you didn't do differentiation of a and b? Again repeating, they are constants. Okay. So derivative of only sin x. So some people, they have, those who have lack of confidence or they are not practiced. Okay. They also write multiplication rule. I don't know why they do multiplication rule with a and sin x. A is constant. B is constant. You can take it out of the differentiation straight away. Let's differentiate it once more to get it double derivative. D square y by dx square. So minus a sin x and derivative of sin x plus cos x. So it won't change the sign. Clear? Now, if you look at this expression on the right hand side, if I take a negative sign common, I left with a sin x plus b cos x. Now, a sin x plus b cos x is nothing but y. So minus y d square y by dx square. If I take this minus y on the left hand side, this will be plus y. And on the right hand side, 0. Now, this is our desired equation. So, this is our question number 11. Let's move to question number 12. Now, look at question number 12. If y equal to e raised to tan inverse x, then show that 1 plus x square y2 plus 2x minus 1 y1 equal to 0. Another way of writing the double derivative and single derivative is y2 and y1. If you have not seen it before, don't get surprised in your board exams if they have given you such an equation. Y1 is dy by dx. Another way of writing the same thing. And y2 is double derivative d square y by dx square. So in this particular question, just to make you familiar, I will use these notations: y1 for dy by dx and y2 for double derivative. Clear? So our y is here equals to e raised to tan inverse x. Let me recall the basic concepts. So dy by dx is y1, and that will be derivative of e to the power something. Sir, e to the power something is e to the power something, and derivative of tan inverse x will be 1 by 1 plus x square. Very simple. Okay. Now at this stage, if you are a beginner, or if you are doing, like, if you have not practiced a lot, then as a beginner, you will make it more complicated. How you will make it complicated? You will simply make it as division rule. You will rewrite this expression as this: e raised to tan inverse x whole divided by 1 plus x square. And you will sit and apply division rule and make it more complicated if you have not done practice. Trust me, you will do, or you must be thinking right now that only. You might get an answer, or you can get an answer at the end by simplifying, but if you are following this, you will get stuck somewhere, because that will become more and more complicated. Better way is simply take this 1 plus x square on the left hand side. So you got this 1 plus x square into y1 equals e raised to tan inverse x. Correct? If you take it on the left hand side, it will be multiplied with that. Now let's differentiate it. Now it's easy to differentiate multiplication rule. It's quite easier than division rule. Right? Easy in the sense, though they both are easy, but here you will get, there is a less probability you will do mistakes. So let's differentiate. Differentiation of 1 plus x square, 2x, y1 as it is, plus differentiation of y1. So what is y1? Let me remind you, dy by dx. So derivative of y1, y2. Differentiation of dy by dx is d square y by dx square. And on the right hand side, e to the power something. Sir, e to the power something into derivative of something, 1 by 1 plus x square. Clear it is? I hope this is clear. Now, sir, can I multiply the whole equation again with 1 plus x square? No. You have to be very careful. You can do that. Same question can be framed in a different manner. But here, if you look at this expression, there is no square here. 1 plus x square doesn't have any square. So now you have to use common sense also while simplifying it. So here there is no square. So if I multiply the whole equation with 1 plus x square, here I will get a square, but there is no 1 plus x square whole square in the final expression. Then we have to think in a different way. Look at our y1. Look at this y1. In y1, okay, right hand side, and here on the right hand side, it's the same. Can I write this as y1 here? This will be 2x y1 plus 1 plus x square y2. I hope all of you understood this. Now 1 plus x square y2 plus 2x y1, and take the other y1 also on the left hand side equal to 0. Let's rewrite this expression finally over here. 1 plus x square y2. Take y1 common, so 2x minus 1 y1 right hand side 0. This is our desired equation. This was question number 12.
Watch the complete playlist on the app Pions. Download the app now.